Hey guys, so these are the notes for applications of square root functions. This is my second time recording this now because the first time I recorded it, I forgot to turn on my microphone. So I'm thrilled to teach this a second time. Sarcasm intended, sorry. I need to get over my bad attitude. Okay, so applications of square root functions should seem pretty familiar to you guys because you do the same steps that you do with applications of quadratics. So I'm going to give you a word problem. There's going to be an equation or a function in it. You're going to go to Desmos, type that function in, and then we're just going to find the value that the question is asking us for, okay? So it should seem very familiar, just like quadratics. I'm not going to actually go over the notes with you. You should have already printed these off or copied them, and they should be labeled as page or section 3 under unit 4. So let's look at the steps really quick, and then I'm going to go through the example step by step with y'all, okay? So for your steps for applications of square root functions, the first thing you're going to do is type in the given equation into a new box in Desmos. So you guys see I already have Desmos pulled up. Second step, we're going to determine what measure was given in the question they're asking. So when they ask you to find a value, they're either asking you to find the independent because they gave you the dependent, or they'll give you the dependent and they're asking you to find the independent, okay? So you have to determine which one was given so that you know what to type in Desmos. And then in a new box in Desmos, if they gave us the dependent, we'll type in y equals. If they gave us the independent, we'll type in x equals so we can find the other one, okay? It sounds confusing. It's really not bad at all. Let's go ahead and get started on the example. So you should have this out with me, doing it with me. So we're going to use Desmos to graph the model. So if you read the question, it's talking about drag racing. I did this one for you, Carson and Simon. They gave us a function that models the situation. It says, the speed can be modeled by this function where p is the power. So instead of typing in s equals 9.8 square root of p, you guys learned last week with systems that Desmos really works best when you type in x's and y's because it understands y to be the dependent and x to be the independent. And it needs both variables because Desmos can only graph functions, okay? So if I go in here, instead of s equals, I'm going to type in y equals 9.8. I'm going to open up my keyboard and do the square root of x because that's my independent, okay? So then if you go look at your graph, it graphs this function for us very nicely. And if you're wondering why my numbers are so big, it's because I already zoomed out, just reading ahead in the problem. But yours may look like this, and that's totally fine, okay? So I graphed it in Desmos. This is a square root function because it's a parabola. I'm going to do it this way. That is tilted, right? So this is my square root function. And then we stretched this one. We did a vertical stretch by 9.8. So it should be a lot taller and skinnier, which it is. So this looks great, okay? All right, so now part B says determine the power of a car. So we're looking for the power, okay? If you look at your equation, the power is the independent variable. So we're looking for the x, which means they should have given me the y. Let's keep reading. Determine the power of a car that reaches a speed of 40 miles per hour. So I gave you the speed or the y, because remember when we typed it in Desmos, we typed in y equals. I gave you the speed is 40, and I want you to find the power, okay? So we can use Desmos to type in that they gave us the speed, which is the y, equals 40. Now, if you look at your graph, there are two different functions intersecting, which means this is just a system, okay? So last week you guys learned with systems that the solution is just where the two functions cross. So it looks like they intersect right here. So I'm going to click this intersection point. And now we do have to use our brains a little bit because a couple of you last week typed in the wrong answer. So let's just look at this. I told you the speed was 40. So 40 is not the power. That is the speed that you typed in. The y value should equal 40. It does. My power is, if you look right here, the X value, which we already talked about. So the power when a car is going 40 miles per hour is 16.66 horsepower. And I am going to highlight that just so you guys know that's the answer. Okay? So easy enough. So this is where the steps are talking about determine the independent and the dependent. You need to know what to type into Desmos and what variable you're looking for. Okay? So for part C, I'm going to get rid of part B because we don't need that anymore. It says determine the speed. So this time we don't know the speed. So remember what you typed into Desmos. You typed in y equals. So we don't know the y value, which means they should have given us the X or the independent. So let's keep reading. Determine the speed of a car with 100 horsepower. So yes, they did give us the P, which was the independent variable. So they gave us, for this one, that the power, the independent X, should equal 100. Okay, I had a couple of you last week ask me how you find this when it doesn't pop up on the graph. We're talking about X being 100. So look at your X-axis. This graph only goes up to 60. So you can click and drag to get over to 100. See, it's right there. Or what I normally do is I just zoom out. So I'm going to hit the zoom out button. And I'm going to hit it one more time so we can really see. Okay. So the intersection point, it looks like if you click anywhere on the graph, or near it, I guess. You have to click near it. Do you see how it pops up with the intersection point? So now I'm going to click on that point. And when the X value is 100, when the horsepower is 100, the Y value or the speed, because that's what it asked us for, right? The Y up here is 98. And we measured our speed in this problem in miles per hour. So that would be your answer. Okay? Easy enough. So this should seem very familiar, again, because we've already done applications of quadratics. Square root functions can be done the same way, and Desmos makes it really easy to graph the system and find the intersection so that you know the solution. Okay? Your steps are all here. You either printed these out or copied them down. There's your example. The homework is just like this. If you have any questions, hop on Zoom and I can help you out. But otherwise, I'll talk to you guys later. Bye.